Welcome back. You guys made it. Today is day 5 of 10 days of base, which means you have made it to the halfway point, right? I mean, for the past 4 days straight, you have been building on base, learning about it, learning all the things like on-chain kits, sub accounts, smart wallets, account abstractions, paymasters, what else? Permissions, spend permissions, all those kind of things. And I know that your brain might probably be spinning a bit, but it's completely normal. It's completely at this point. I'll say that it is completely normal. It's fine. It's going to spin a bit more in the coming days, but totally fine. But here's the thing. You guys weren't just learning, like you guys were building stuff, coding, sharing it on Twitter. Like I saw a lot of posts regarding all the things that you are building. Well done, great job. And we are at day 5. Like if you go to the challenge calendar, we are here, right? So now the thing is, when you look at day 5, since it's the halfway point, we wanted to bring everything that you have learned so far into one place so that you can just experiment with everything rather than, like, we've been learning parts of it, and day 5 is where you just put everything together, right? You can see that the whole task is to create a fully featured front-end application, which means you need to create the contract and the front-end, which is pretty easy now that you've learned a lot of concepts and you've been working with a lot of stuff. I mean, we have been building, like, smaller front ends here and there, but today you get to stretch your creative designer muscles and just work on a full end application. Now, so here's what I'm going to do. Like, I mean, so this video is more of a walkthrough rather than a tutorial, because like, it's up to you, right? Like, you have the knowledge, you have all the things, all the features, you've learned about all the features and stuff. So how you want to do it is completely up to you. Like, I will give you a walkthrough of how I would approach it, like, what kind of application. I think I'll just stick to a basic voting application to see like how to show you how things work. So I'll create the contract, set up the front end, let it interact with it, and show you how everything works. But again, so I don't want this to be a one of those videos where you can just follow along and just build the same thing. No. So you guys are free to create your own applications. Like, I'll show you my version, and in order to make the things a bit more interesting, I think rather than typing every single line of code, which I've been doing for the past 4 days. I mean, I know that I've been copying some of the lines, but most of the time I've been typing it. So yeah, it counts. So I would say, like, today I'll show you how to create the contract and everything. But for the front end, I was thinking I'll do a bit of vibe coding, right? Because it's pretty cool. Like, it especially for creating front end and stuff. Vibe coding really helps, and it's very convenient. So I'm thinking I'll do a bit of vibe coding for the front end, and I'll show you how to create a contract. Even, like, better yet, the thing is, we can even use some of those AI code editors and stuff to write absolutely beautiful tests for our contract. So yeah, I can. So I'll show you how to write the contract. We will use AI to write, like, tests so that our contract is secure. We'll deploy it on chain. We'll use the ABI, and we'll create a front end for it. So, and I'll show you how the whole thing works. And so, like I said, so this is sort of like a walkthrough of the whole thing of how I would approach it, and you guys can take it and build your own application and even implement any or all of the things that we have learned so far, right? On chain kit, or paymasters and everything. So I'll show you my approach. It has a lot of vibe coding. Like, we will write the contract. Like, I'll show you the contract in case there are people who are new to this whole thing. But yeah, I guess this is going to be a fun one, because we are trying something pretty cool. Like, we are not going to write a lot of code, and I get to yap a lot. So yeah, it's going to be fun. Let's go. All right, so now that we know what we are up to, let's just get right to it. So the idea is we'll create a basic application, like a complete application, contract, front end, everything. And like, I'll wipe code a lot of the front end and even show you how to use AI to create tests for the contract. So it's going to be a very basic voting contract. So the idea is we'll create a contract that can right, using which we can create proposals. People can come in and vote for these proposals. There will be a time limit, and once the time limit ends, we will check whether the proposal has got more approvals than rejections, and if it has got more approvals, we'll just set it as approved, right? So yeah, so that is the general idea of the proposal contract. I mean the voting contract. So yeah, let's just go ahead and build it. Now the thing is, like for creating the contract, we'll use a framework called Foundry. Like I'm pretty, like you guys know this. Like we have already introduced this. So the thing is, Foundry is pretty cool. Like it's a complete, Ethereum development framework. It comes with a lot of amazing tools, and you can just directly install it using these three commands. Like this works fine in Linux and Mac, but if you guys are using Windows, you'll have to install either Git Bash or WSL, because Foundry relies heavily on like Linux-based terminals and stuff. So yeah, make sure you have something that can emulate that, like those who are using Windows. So yeah, for Linux and Mac users, this is going to be pretty easy. Like you just have to do this. Like I've already installed it. Yeah, I've already installed it, so but I'll just give you, I mean, it's pretty simple. Just copy this and paste. So it will just download Foundry and just type Foundry app, and it will just set up the whole Foundry tools. Now the thing is, like, if it comes with a lot of really cool tools. Like Forge is like your command center. Like it helps you create new projects, build, test, deploy contracts, and everything. Right? Then you have Anvil. So Anvil is sort of like a local deployment, like local blockchain or a local dev chain that you can run in your system, and you can test your contracts and stuff using that, right? And then you have Cast. So Cast is sort of like an interaction tool. It's a terminal based interaction tool that helps you interact with applications that are on chain, right? So yeah, you can just use these commands on the terminal, and yeah, you can just interact with the contracts, which is pretty cool. So Foundry comes with all these cool tools and a lot more stuff, which makes the whole development process pretty easy. So that's why we keep pushing Foundry. And the best part is, like, I don't know how many of you know this, but the thing is, like, the Foundry framework is written in Rust, but the whole scripting and everything in Foundry actually happens via Solidity. So if you know Solidity, you can work with Foundry pretty easily. So yeah, so that's why we promote Foundry, because a lot of you guys might be familiar with Solidity. Newcomers especially will be found very familiar with Solidity. So yeah, you guys can just get started with Foundry because it's pretty easy. So let's me just create, like, once you've installed Foundry, just type in Forge and see if this thing comes in. This means that a Foundry is properly installed. Let me just clear it, and let me just create a new project. So Forge init voting. Oh wait, contract. Oh, dude, I made a small mistake. It should be okay. So yeah, test. Right. Okay. So yeah, right. So once you do that, like the entire thing will be set up. Like your whole project structure will be set up. Like it has a library folder where all the libraries and everything, like the Forge standard libraries there. You can install other libraries too, like OpenZeppelin and everything. So all that will be there in the library folder or the lib folder. Then you have the script. So this is where you write the script for deploying the contracts and stuff, right? Like interacting with the contracts and deploying and everything. Then you have the source where you write the contract itself, and you have the test folder where you write the test for the contract. So it comes with a default contract and script and everything, like a basic counter contract. But we're going to delete that and create our own contract. So let me just remove all this and test. Right. So yeah. So now I guess we can just go ahead and create our contract. New voting contract.sil. So yeah, I think we'll just start with the basics. Oh, we have the pragma 0.8.0. Before that, we have to give the SPDX license identifier. I thought it comes with both, but yeah, SPDX, please. Yes, there you go. So right. So the general stuff, like, which is the license identifier, so that there is no issue with, since like this thing is going to be on chain and everybody can see it, we just put the licensing just like any other open source material, right? And you have the pragma, which defines the compatibility version, like which version of the compiler will our code be compatible with. So once you have both, let's just go ahead and contract. We'll just call it voting contract. So, voting contract. And yeah, so we can just go ahead and define our contract. So like I said, it will be a proposal. So I'll just create a struct called proposal, right? So within the struct, we'll have a string description, uint 256, yes votes, not whites, votes, uint 256. Oh, I don't know what's up with my mouse pad. No votes. What else? We have to check if the proposal is active, right? And then the time, which is like end time, like the, yeah, and bool approved, right? So yeah, so this is the basic stuff. Like you, when you set up a proposal, you have the descriptions, you have the number of yes votes, no votes, whether the proposal is active, the time that the whole thing ends, like the proposal, you know, the voting of the proposal ends, and at the end you can check whether it's approved or not, right? So yeah, let's just go ahead and create an array for it. Wait, yeah, proposal public propose self, right? So yeah, we have the proposals, which where we will store all the proposals. And next, what we are going to do is, so the thing is, every proposal, so we are going to keep it simple. So this is basically an array. So we are going to use the index as the ID for the proposal. So what we are going to do next is we need to track whether somebody has already voted against or for that proposal, right? We need to keep track of the votes. So we'll just create a mapping. So what we are going to do is, it's uint 256, and we'll create another mapping, which is like address and bool. So what this means is, public has voted. So what this whole thing means is we are going to check, like we'll put the index of the proposal. Like once we create the proposal, we'll just add it to this array. So the index of this proposal will be the ID of it. So we'll check the index, and then we'll check the address that is voting against, like voting for that proposal, and we'll check whether the person has voted or not, right? So this is a mapping within a mapping which checks whether a particular person has voted for a proposal in that particular index or with that particular ID, right? So the next thing is, like, so what I'm going to do is, like, we can't let everybody put a lot of proposal in it, so we might need to have a set of pre-approved addresses that can actually propose these things. Like we need a set of proposers, so we are going to create a mapping for that mapping, oh, sorry, address, and we're going to say bool public is approved proposer. Okay, so what this means is, we are going to create uh, a list of addresses that can actually propose this whole thing, right? So next we have address public owner. We're going to set an owner for this, and yeah. So once that is done, like, let's just set up a few events. Event proposal created. It's going to have uint 256 proposal ID string description, What else? Event 256 and time. Right. So yeah, then we can have an event podcast. Um, yeah, just for the simplicity of it, event 256 proposal ID, address of the voter, and of course, we can also track the vote. I mean, it's yeah. I mean, why not? Typically, you don't need the. Yeah, we'll just skip the address part because I mean the vote part. Like we can say that people have voted, but let's not reveal whether it's for or against, right? So yeah, event um, proposal. So when the proposal closes, I think we need one. So proposal closed. Need 256. Proposal ID. Bool approved. Right. So yeah, it will say the proposal ID and it will just send whether the proposal is approved or not, right? And same for the I guess the proposers like we pro proposer approved, right? So we'll just give the address proposer, and I think we'll have an event for proposer revoked or removed address propose. Proposal. Yeah. So pretty simple. So these are the events that we are going to keep track. Yeah, this is for when the proposal is created, when somebody casts a vote, when the proposal is closed, when a proposer is approved, and when a proposer is removed. So yeah, so let's just go to the constructor. Constructor owner message.sender. Yeah, I mean, of course, a very typical constructor. We can also have a modifier only honor. So here like so this modifier basically checks require message dot sender. So this one checks whether the person who is calling a function is the owner. Otherwise it will just say not authorized, right? Okay. And yeah, wait, you need to give this right. uh, Yes, so once that is done, I guess we can have a function for approving and removing the proposals because we need proposals to actually get started with the proposals. So wait, function, yeah, function approve proposer. It's going to take an address and it's going to be the proposer address and it's going to be public and only owner because only owner gets to call it. Only owner gets to add or approve proposals. Proposer equals true and we can emit the proposer approved and proposer, right? Okay, so once this is done we can do the same thing and create approve remove proposer, right? Remove proposer, it's going to be false, right? And emit proposer removed, actually, sorry, removed, right? So yeah, so this is the whole process. Like we have two functions, approve proposals and remove proposals. Now let's go ahead and create I guess um approved proposers. Yeah, once we have the proposers, I guess we can set the owner also as the approved proposer in the constructor, I believe. Yeah, I guess is approved proposer owner equals true. So the owner can also propose it. All right. So yeah, so that is there, and so we need one more modifier, I guess. So before creating the proposer function, we'll just say only approved proposers, right? So this means that the person requires is approved proposer message dot sender. So the message dot sender has to be an approved proposer, otherwise not an approved proposer, right? Okay. So again, this is pretty clear. Like we just check the list. Like when somebody calls the function to create a proposal, we will just check whether the person is approved or not. So by default, we have given the owner as an approved proposer. So yeah, otherwise, yeah, I mean, why not? Right. So yeah, um, yeah. So we have. I mean, this is basic. Like you can think about all the other logics, but yeah, I'm just keeping it basic. Function create proposal string memory. We're going to need a description, and what else? I think we just need everything else is okay. Yes vote, now vote, active. Yeah, yeah, yeah. So we just need the end time, right? So the duration. Mm, duration of it. So yeah, so duration can be in seconds, like we can give anything in seconds, and it will be yeah, we can just add it to the block timestamp. So yeah, so it's going to be public. It's going to be only approved proposers, and it returns the ID UN256. Awesome. So yeah, so we have our proposal, and what we are going to do is we are going to create the end time first. End time is equal to block dot timestamp. So when this is added plus the yeah, duration, right? Um, oh, okay, okay. And time, okay, and use local variables, of course. So yeah, so let's just go ahead and create our new proposal. Proposal memory new proposal equals uh, proposal brackets this description, which is going to be description, right? What else? Yes vote is going to be 0. I'll just copy it so that we don't make any mistakes. I mean, with the naming and stuff. So yeah, we'll just remove all these things. Yes votes, no votes, active, end time, and approved, right? So yeah, description is going to be the description. Yes vote is going to be 0. No vote is also going to be 0. Active is going to be true. What else? End time is going to be our end time. Like I'll just put a so that we know. Yeah, end time, and of course approved is going to be false. Right. So yeah. So this is the general stuff. Just going to Okay, so yeah, so we have created a new proposal. We have the description set up. Everything else is basically default except the end time, which we have set as block time plus duration. So next what we can do is we can just push the new proposal to the list. So I'm just going to say proposals dot push and new proposal, right? So yeah, so this is going to be the index of the proposal. So yeah, and we can say event 256 proposal proposal ID, right? Proposal ID is going to be proposals dot length. I saw the length. Yeah, length. Right. So this is going to be the proposal ID because uh, if we add it, I guess length plus one is better because no, yeah, length is good. Uh, no, we'll just set it as like a minus one so that it is easy for us to index. Right. Yeah. So we'll just keep it as the index itself. Right. So yeah, and then we'll just emit proposal created proposal. Oh yeah, proposal ID description and yeah, end time. So yeah, this looks pretty good, decent, and we'll just return the proposal ID. All right, so we have one function down, like we just need a bit more, I think a couple of more to complete the contract. So yeah, this one is done. Now let's just, once we have the proposal, we can vote. So let's just go and create the vote function. So function vote. So you can in 56 proposal ID bool vote. Oh, again, it's a convention. I mean, it's not a convention. It's like something that you. It's a style, right? So the proposal ID should be less than, yeah. Otherwise, proposals dot length. I mean, of course. Otherwise, pro does not exist, right? What else? Proposal storage. So proposal. So we'll get the proposal, which will be equal to proposals proposal ID. So this will get us the proposal that we are going to propose against. We need a couple of stuff. We need to check whether the proposal dot active, else proposal is not active. We can't vote for a proposal that is not active. So require. Then we need to check the timestamp block dot timestamp should be the lesser than proposal dot end time, and yeah, voting ended. Require. We also have to check whether the user has voted, right? So has voted the proposal ID, like I said. So we are just checking if this message dot sender has voted for this particular proposal that has the ID. So all already voted. Right, so yeah, so this is the basic stuff. Like we have set up all the basic, already voted and everything. Now let's just, the first thing is we have to set the has voted. So proposal ID, message dot sender we are going to set it as true. All right. So yeah. Uh, so and we are going to say if vote, meaning if a vote is true, proposal dot yes vote plus plus, right? Else proposal dot no votes plus plus. All right. So yeah, and we'll just say emit vote cast proposal ID and of course message dot sender. And yeah, I guess that's it. We don't want to reveal the vote. Uh, oh, what is the name? It's a vodcast. Oh, okay, sorry. Uh, okay, and we are done, right? So yeah, okay, yeah. So we have created the proposal, and right now we have voted for it. Now we can actually close the proposal. Like we can have a function to close the proposal, right? So for closing the proposal, what we can do is function close proposal, meaning so when you're trying to close the proposal, given 56 proposal ID, yeah, so it's going to be a public function, but don't worry, we'll go require proposal ID. Yeah, you need this check basically. I'm not going to type it again. Let me just copy it and paste. Okay, so require proposal ID, and we'll just get the proposal one. This step is pretty much the same. Oh, wait. So yeah, once we have the proposal, I think this is also something that we can check, right? I mean, okay, and right. So this one is also there. So here we'll make a slight difference. So this time we're going to check it's greater than or equal to, and we can just say voting ongoing, right? So yeah, so this means like if the timestamp is greater, that means we haven't reached the end time yet. That means the voting is ongoing, and we can't do we can close it, right? Else we'll just say proposal dot active equals false, right? Proposal dot approved equals, so for approved we'll just check pro, proposal dot yes votes greater than proposal dot no votes. So if this is true, it will set approved as true. If it's false, it will set as false. And emit proposal closed, proposal ID, and proposal dot approved. Right. So yeah, that is it. I think we can also have get proposal thing so that people can see the proposal. So yeah, we'll just say function get proposal self. Okay, event 256, which is going to be the proposal ID. I thought I won't be coding much, but yeah. I mean, this is the only part that I'm going to be coding. Rest is going to be wipe coding, so it's fine. Public view returns. So it's going to return a couple of stuff. Let's just say string, memory, description. Yeah, wait, I'll do something. Just copy these things so that we can easily return this whole thing, right? Yeah, so paste it here. Okay, string, memory, description, copy, import. Yes, yes, so easy. Okay, so yeah, so these are the things. Now we need to do the basic check, which is this one, right? We need to make sure that we can get the proposal, right? So yeah, and return description. What else? Yes votes, no votes, end time, and approved. Okay, so yeah, so this is what we are going to return. Oh wait, okay, right. What else? So yeah, we have the get proposal, and we can even have a proposal count if you want. I mean, why not? Function get proposal count, and it's going to be, doesn't take in anything. It's like public view returns. What does it return? It returns a UN256, and yeah, return full start length. Right. So yeah. So this is basically all there is to it. We have our contract, like it has everything. Now let's just use a bit of AI and write some tests for it and see if we can get the coverage. Right. So yeah, let's go. All right, so now that we have created our contract, let's just go ahead and compile it and see if everything is proper, like if there are any issues with the syntax and stuff. So forge build, we'll compile it. Yeah, I think, yeah, these are like suggestions, I guess, notes, but the compilation was successful. Again, there is always scope for improvement. Like this is basically a simple contract that I want to showcase, like how we can use to create front end and everything. But like if you look at the out, you can see, yes, like it's properly compiled. It has all the stuff. So yeah, I guess the compilation is done. Now what we can do is we can just go ahead and use another AI based code editor. Like you have Copilot here, but I will actually, I mean, I prefer something called, of course you guys know this, it's called Windsurf. Right. So Windsurf is AI based code editor. It looks just like VS Code. I mean, and I love the functionality. I mean, it's pretty good. So like I've opened the folder in Visual Studio, sorry, Windsurf. I'll just clear out the whole test folder. Yeah, there is nothing in it. So yeah, so I'll write a couple of prompts to actually give it uh, you know, like make it write a few tests and run a few coverage. So the thing is, when you're writing tests, make sure that you aim for better coverage. So coverage means the amount of code that your test covers, and it's always good to have the coverage percentage above, I don't know, 93, 92, 93 percentage. That means a good portion of your code is properly covered. So let's just go ahead. So I'll just write uh, boundary test cases for the voting.sol, which is the contract in source, right? In source. So this is the command. Now I have a bit of requirements. So those requirements include use or yeah, I would say each keep a different tests in different files inside the test. The test, why is it not detecting the test folder? Okay, I think I'll just give it the test. Okay, the slash test folder. What else? Uh, okay, I'll just ask it to follow the best practices, best testing practices for Foundry. What else? Cover all public, cover all functions, mo modifiers and events so that we know everything works. And yes, this is really important. Like we need to check if everything is working properly, and we also need to check if the things that are meant to fail should fail, right? So failure cases and handle edge cases, right? I'll just say aim for at least 93% or more. Yeah, that is the meaning of at least. Total code coverage, right? And use clean or clear function names for test. Add a brief comment explaining each test. What else? For the test files, use a common naming standard like name dot t dot sol, right? What else? So these are the requirements. Should we do anything else? Uh, yeah. Okay. So yeah, after writing the tests, uh, verify the coverage using forge coverage command. Verify the coverage using, and we'll just say if coverage is below 93%, add more tests to close the gap, right? Okay, so this is the general stuff. Like I've given the voting contract out soul, and yeah, let's see if this thing works. I mean, it's pretty cool. I'll help you write comprehensive. Yes, it's analyzing the whole contract test plan. Let me create the test plan. Okay, let's see what. Okay, test file for deployment and initialization. Okay, cool. Oh yeah, it's you can see that it's following the whole thing. Like I love it when it just yeah. Oh wow. Okay, so you can see notice test is right. Proposer management. Oh, and it's writing the text for the proposer management. Should not be approved. Yeah, I mean look at this. You have two users, test the owner, it test owner is approved, owner should be approved proposer, no, not approved. Like, it has all these tests, proposer management, removing, okay, approving and removing proposers. Oh, wow. So it's basically covering everything. Proposal creation, you can see all the test files coming in. So yeah, like, these are big test files, like, just creating a lot of like really cool test files. So just make sure, like, when you're writing these things, like, make sure it's pretty much, uh, oh yeah, make sure there are no typos. Like, I have made some typos, but yeah, other than that, create functionality. Okay. Voting. So for each of the functions, I guess it's creating separate, like each of the functionalities, it is creating a separate test, right? Like for voting, for proposal, for proposer, for deployment. So it's covering, so that's why I said, like, it writes really, really good tests. And, you can, like, Forge actually has a really extensive testing tool. So the coverage thing and everything basically helps you understand every part of the code. Like, it helps you understand, like, what or how much of this um, you know uh, code is covered by the uh, like tests that Windsurf has written. So yeah, you can see proposal closing. So for every single functionality, I think they are writing like crazy amount of tests. So I won't be surprised if our coverage is like 200% or something. Maybe it just runs through every file twice. I don't know, but let's see. You can just do accept all, and yeah, view functions, if it's even testing the view functions, which is fun. So yeah, you can see, I mean, the new model is crazy, like the Sonnet 4.5. I just recently upgraded the IDE, and it works really, really good. So yeah, I guess it's creating test file for view. So yeah, everything is properly tested. Like, one file is like 300 lines of code, right? So the thing is, there are different kinds of tests also. That is why it is like, uh, you know taking a lot of these things. So the thing is, there is, I don't know if you've seen this, like, there is something called first test. So first test, as the name sounds, it's basically you throwing in a lot of like a random stuff, like unexpected inputs, just to see if it breaks. So that is a very powerful testing thing. So it covers a lot of edge cases. Like, if we do proper first testing, we can cover a lot of edge cases. So there are actually different type of uh, tests that you can do. Like, first testing is one of them. Like there is unit test. Then there is, like, unit test means you take, like, what unit tests are like, functionality of the individual functions in the smart contract. It's like, we expect a certain thing out of it, so we check for it. Um, so then there is something called as the invariant test. So invariant test is also a special type of first test. So the idea is we ensure that specific properties of the smart contract always remains true, right? So you can learn all about it. Like, there are a lot of yeah things. So let me just run this. It's compiling. Let me just take it to the terminal. Oh wow! Look at that. Look at that. You can see all the tests have passed. Wow. Let's run the coverage thing and see how we have done. Oh, wow. You can see, like, we have a pretty good coverage, right? Yeah. So this is pretty good. Like, look at all the coverage. Like, we have 100%. Wow. We have covered basically everything. And the coverage is pretty much like, we did some 89 tests on it, and 89 of them has passed. So I think we have covered pretty much everything. So yeah, right now, like, we have a pretty solid contract that is tested using our uh, you know friendly neighborhood AI editor, Windsurf. and it has given us pretty good coverage too. So yeah, let's go. We have a solid contract. Let's just go ahead and try and build the front end using the same thing. All right, now that we have a heavily tested contract, let's just go ahead and deploy it onto the chain. So for deploying the whole thing onto chain, we did a couple of stuff. First, we need an account. You can use MetaMask, you can use base account, it's fine. So it's just MetaMask because, yeah, it's familiar. So in MetaMask, what you have to do is you have to add the base Sepolia. Make sure that you have a few tokens and add the base Sepolia or testnet. So one of the easiest ways to add it is just go to the base Sepolia Explorer, and at the very bottom of this thing you have add base Sepolia network. I've already added it, so it's fine. And once you have it, you can just create an account in the Coinbase developer platform, and you can get some free tokens, right? So I already have an account. Uh, yeah, okay. So you can just check the wallet, pause it. It'll give you some tokens, right? Pretty easy. It's quite generous. I mean, it like you don't need much of it. You just claim it, okay, and get more funds. Yeah, you'll get tokens. So make sure that you have these things, and we also need the yeah. You can see. So you also need one more thing, which is the private key and the RPC URL. So for that, let's just go to our contract. Let's just create a .env file. Give me a second. .env. Make sure that it's inside the. Oh wait. Wow. Yeah. I created it inside the test. Okay, so here we'll just say RPC URL, and so a base has a general test RPC URL. It's a very simple stuff like for Sepolia. I'll just copy and paste it. Copy this, paste it here, and you know how to get the you know faucet. I mean the private key. So just go to your MetaMask account, click on this account details, private key, give your password, and just hold on to this. But yeah, I'll do it off screen so that you know, again, it's not a good practice. That's why. So yeah, let me just get the private key. 1 second. So yeah, if you click on it and you will see the private key, you confirm. Okay, you can just copy it. Let me just do it off screen. Again, I don't. Okay, so I have added the private key to our .env. So everything is set. Now let's just go ahead and deploy the whole thing. So again, I'll be using a command for it so that it's easy. Like I don't like to write another script. Yeah, think of you can think of whatever about me. I'm fine. Like I'm lazy when it comes to a lot of typing. So yeah, let's just go ahead and clear all this. So the command is pretty simple. Forge create src slash voting contract and just put the name of the contract, or not this one, sorry. Yeah, it's voting contract. Yeah, voting contract, and we have to give the RPC URL, and oh wait, wait. So before this, we have to do one more thing, which is source our .env so that our terminal can pick it up. Yeah, now let's just forge create src slash voting contract underscore no, I mean colon voting contract, and I'll just say RPC URL and private key, which is again private key. Okay, and broadcast. Oh wait, broadcast. Right. So yeah, this will put our contract in the base Apolia via our account. So let's just put it, compiling. There you go. So yes, we have successfully deployed our contract. Now there is one more step, like for the front end, we actually need something called the ABI. So yeah, we need to get the ABI of the contract. So I think there is a command for it. Let me check. So just like the whole Foundry thing, we need, okay. So I think once we have it, I think it's already there. Um, so once you have it in the out, yes, so you have the whole thing here. I'm just looking at the ABI, which should be, where is the contract? Just give me a second. Ah, yeah, waiting contract. Sorry, I mean voting contract. Yes. So yeah, so this is basically the ABI. Like we have the whole ABI thing. We will use it, you know, for our like front end. So yeah, you can. So we already have it. Maybe we can try and paste it in. You know, no, I think we can just use the JSON. It's fine. Like since we will be vibe coding, we can ask AI to do all the stuff. So yeah, there you go. Let's just go ahead and build a front end around this. So yeah. All right, all right. So now that we have deployed the contract, like let's just go ahead and create a front end around it. Now the thing is, there are a couple of ways to do it. Like we can set up a basic project structure and then ask the AI to take over from there. Like you can set up a base on chain kit, um, you know, use that framework to basically create a scaffold and then ask it to just go over it and make the changes, or you can just make AI do everything. Like I prefer the first option, but since we are vibe coding, let's just make AI do everything. So let's just go and create a prompt. Yeah, so this is our testing. Let's just go ahead and create another form to do this. So let's go. I mean, so what we're going to do is we are going to set the goal, build a full featured modular responsive frontend for the voting contract that is deployed to the base Sepolia testnet using the latest base on-chain kit, right? So first, uh, analyze the base, the latest base on-chain kit docs and understand the implementation, right? So these are the requirements. So I'll just give it as the requirements. The requirements, right? So we just need, so this will actually do the research. It's pretty good. Now we need, okay, okay. So that is, okay, this is not the requirement. This is actually the scope. Then we'll say allow you, since we have deployed it via our MetaMask, and we are we should also let users vote via their base. So we'll just say users to connect via their base account using the base account SDK, and then we can also allow users to connect via the MetaMask account. Then we need display real-time contract events. Yeah, interact with all the public functions of the contract. I don't think we have external. So be fully responsive, visually clean, and follow a modern design style with. Now there is a pattern where you can just give it as a readme file and ask it to read out of it. But yeah, I mean it works for bigger projects, but this is simpler. That's why I'm just typing all out as a prompt. Smooth UX, right? So this is the scope. Anything else to add? Latest on okay. Yeah. So this is done. Now let's go for the requirements. Okay. So for the requirements, okay. So wallet connection, we need base account via, I think onchain kit also allows it. Onchain kit, research, latest talks, MetaMask via, yeah, I think MetaMask, like it has a default thing. Detect, we can just say detect connected wallet automatically and switch UI context, right? Okay. So it's going to be, if done well, it's going to look pretty cool. Uh, yeah. So yeah. So next we need contract interaction. So for that, analyze. Oh, we'll just give it as points. So sorry. This is point and MetaMask. I detect. Okay. So detect. So contract interaction. So for that, analyze the contract ABI in, I think, voting contract dot, there is a voting contract on JSON, right? Oh wait, where is it exactly? Out. Yeah, voting contract dot JSON. Why is it not picking it up? Let me just check. Voting contract slash out. Oh, is it because it's okay? Oh, okay. Maybe it's because. Oh yeah, I'll just give the whole location. Out slash voting contract dot sol slash voting contract dot JSON and interaction with the contract, right? So in dot slash, yeah, okay. Just get the location so that it's relative path. Yeah, just give the location here. Yeah, I mean it's basically the same. So yeah, it's fine. Okay, so next, yeah, so you have to handle this. Then I think handle failed transaction with user messages. Yes, subscribe and display all relevant contract events live, and then it's the front end architecture. So use on-chain kit scaffold, search online, and yeah, we'll just ask it to use that. Uh, make sure there are proper subdirectories and components folders, and use tailwind 3, right? And follow modern minimal design style. Okay. We can also add something like soft shadows. What else? Gradient. I mean, gradient buttons. I don't know if it's minimal, but I'll just say modern and sleek, or maybe futuristic is good. Futurist, futuristic design. Yeah, I mean, gradient is not minimal. So card layouts and smooth hover, right? Yeah. So yeah, I guess this is it. Um, we can just say before starting the project, analyze quoting contract dot sold and as evaluate functionality. Okay, let's see what it does. Language using, okay. Oh, it's prohibited. Okay. So I guess it will create its own stuff based on what we've added. So it's creating the next app using the on-chain kit. You can run it and take it to the terminal. Yeah, so we can just name it voting Frontend. Not now. Nah. Okay. So yeah, you can see how all of these steps So again, now there is a more structured part to it, like I said, like with the whole creating the documents, setting the steps and everything. Personally, I feel like it's more of like a trial and error when it comes to prompting. Like give it a context, give it a structured thing rather than just putting everything as a blurb. So that kind of works. I mean, that gives you a pretty good output, and then you can you know like I'm hoping that there will be some issues that we need to fix so that we can see like how things work, right? So yeah, once it analyzes the contract, I think it will also set up the ABI for it, so it's fine. Yes, it's installing the whole thing. I think there are a lot to install. Let me just check the package with you. Huh. Okay.
A few moments later.
All right, so I guess our front end is created. Like you can see that it's quite extensive, lot of components, lot of everything, and the whole AI basically went ahead and created its own ABI and stuff like in utils, I believe. Yeah, you can see that. So it will use that, and we have the env where we have set up the contract address and all the API keys and stuff. So let's just go ahead and try this out and see what our AI has done. Npm run dev. So yeah, we'll just set it up. Just give me a second. Yeah, it's compiling. Let's see if the. I mean, there might be issues like even I had to do a bit of prompt to fix a few, design issues here and there. But yeah, there might be issues, But okay, this looks nice. Okay, right. So let me just connect the wallet. Okay, wait. Okay, yeah. So yeah, you can just connect the wallet. I'll just click on MetaMask. Wait. And I'll just connect to the account. And yeah, I guess, okay, there you go. You can create a sample proposal. Again, you can set the date, which is like, I'll just say 1 day, create proposal, and it confirms. Okay, proposal created. I believe it will. Okay, so if you go to proposals, there you go. Okay, I think, yeah, oh wow. You can see that, and we can still vote for the proposal. See, there might be some UI issues. So again, but we generally have a pretty neat, front end, and you can see this whole thing, right? Proposal zero, we have voted it yes, and yeah, we can go ahead. Oh, look at that. So yeah, I think I might have to check the events thing, but yeah, I mean, again, you might just have to prompt it a bit more and fix up the events and everything. But yeah, so this is how generally things work. Like you can get the whole thing, you can see the proposals, you can see that the like the hours, one vote, all those kind of things. So it's pretty cool. And yeah, I mean, this is how you wipe code the whole thing. So do try it out. I mean, I won't ask you to try the voting tab. You can just try out anything that you want, like based on your own, taste, your own ideas. But yeah, it's pretty easy. Like you just need the proper contract and the API and stuff, and yeah, so that's it, I guess. Like this is how you create an end-to-end dApp. Like you have the contract and you have the front end. So yeah, go try out something cool, because day 5 is all about you being creative. So yeah, I'll let you guys do it. So yeah, see you on the next day.